Yes, sir.
Okay. That supremum and infimum of a set. Right. Today I would like to give a notion about topology of one point topology set. So point set topology. So in this connection, we like to give a definition of neighborhood of a point, epsilon neighborhood of a point. Right. So let me start the definition first. Let us take any S is any subset of R. You start with any positive real number, and you take any element which is in S, or else you don't take like this. Don't consider A. In fact, just take a point. That's it. Take a point. Epsilon neighborhood of a point simply denoted by a point A, simply denoted by in Rudin, according to Rudin. This is a notation. Set of all points which are in a real line such that the distance from X to A should be less than epsilon. This is my real line. Take a point. This is my distance. This is my distance from A to, with a distance epsilon, A plus epsilon. That means what? This is nothing but A minus epsilon. The distance from here to here is epsilon. So set of all points lying between, in this region with a distance epsilon, with a distance less than epsilon. What is this exactly? Set of all points such that when you simplify this, what you get? Minus epsilon, x minus a less than epsilon. That means set of all points in R such that a minus epsilon less than x less than a plus epsilon. That means this is exactly set of all real numbers lying between a minus epsilon to a plus epsilon. Set of all real numbers lying between a minus epsilon to a plus epsilon. It's exactly precisely a minus epsilon, a plus epsilon. Therefore, what is the definition of neighborhood? Neighborhood of a point, epsilon neighborhood of a point, simply a bounded interval, a minus epsilon, a plus epsilon. Right? That means precisely when you want to say x is in the neighborhood of epsilon neighborhood of a, if and only if the distance between x to a should be less than epsilon. The distance between x to a is less than epsilon. So this is very, very important fundamental definition in Rudin. So in order to say that something is in the neighborhood, right, you want to say that suppose x is a point which is in the neighborhood, it's enough to find the distance from that point to x. So the distance, according to geometry, the distance between x to a is simply denoted by x minus a. This represents distance between x to a, x and a. So x and a. So in order to say that x is in the neighborhood of a, epsilon neighborhood of a, it's enough to show that the distance from x to a is less than epsilon. If you show this, then x is in the neighborhood, epsilon neighborhood of a point. Suppose, for instance, you take an example. Suppose you give me real number. Suppose you take epsilon is 1. It's a real number clearly. So give me epsilon. Suppose you take 0.1. So what is my neighborhood? Epsilon neighborhood of a point? Simply the definition is a minus epsilon, a plus epsilon, which you have seen already, right? A minus epsilon, a plus epsilon. In usual metric space, R, we'll see later when I deal with metric space. So this is not a minus epsilon, a plus epsilon. So what is my a here? My a here is 1, 1.1, 1 plus 0.1. That means this is nothing but 0.9, 1.1. That means what? The set of all points, this is my center, and this is my 0.9. This is what actually 1.1. So set of all points lying between 0.9 to 1.1 is nothing but epsilon neighborhood of a point, 1 with radius with radius epsilon. So this is simply call it as epsilon neighborhood of a point, neighborhood of a point A with radius epsilon. With radius epsilon. Right, this is what neighborhood of a point. Right, simply A minus epsilon, A plus epsilon. Just you keep, when you go through the real analysis, when you go through the basic real analysis, what is the epsilon neighborhood of a point? Simply open bounded interval A minus epsilon to A plus epsilon. A minus epsilon to A plus epsilon. So next is neighborhood of a point. Next you can take, in fact, before that, you can take a deleted neighbor. These are the terminology. Delete a neighborhood. So delete a neighborhood means this is my epsilon neighborhood of a point. Just you delete the center itself. This is what actually delete a neighborhood of a point. Just you throw away the center. This is my neighborhood. A minus epsilon, A plus epsilon. Just you remove this point. Just you remove this point. So this exactly, what is this? Epsilon neighborhood of a point, delete with this A. But epsilon neighborhood of a point is nothing but A minus epsilon, A plus epsilon minus A. Is exactly A minus epsilon to A union A to A plus epsilon. Just deleting A, just center itself. This is what actually delete a neighborhood of a point A. For instance, you take example, A is equals to, suppose you take 2, epsilon is 0.1. What is my deleted neighborhood of a point? Simply A minus epsilon, A plus epsilon minus A. And that is what A minus epsilon means 1.9, A plus epsilon is 2.1 minus 1 itself. That means 1.9. This is my 1. 1 point, this is my, sorry, 2. Center is 2. This is 1.9. This is 2.1. Right? So therefore, just throw away the center. That means what? 1.9 to 2 union 2 to 2.1. This is what actually my delete a neighborhood of a point is. Just delete the center itself. You get that actually delete a neighborhood of a point itself. Right?
So excuse me, sir, why are you taking epsilon values always in points, sir, less than 1?
You can take epsilon 1 also, no problem. Epsilon 2 also you can take. If you take epsilon equals to 100 also, that's wrong.
Okay, sir.
You can take epsilon is equals to 100. Why don't you take epsilon 100? You can take any positive real number. What is my definition? Just look at my definition. Epsilon is any positive real number. You can take anything. Understand? That's no matter. So this is what actually my epsilon neighborhood of a point. Next is neighborhood of a point. Neighborhood of a point means, suppose you start with the subset. You start with a member which is in S. So S is a neighborhood of a point. If only if there exists some epsilon neighborhood of A, there exists some epsilon neighborhood of A. See, don't use this notation. Just you can use this notation. Epsilon neighborhood of A means A plus epsilon, A minus epsilon, A plus epsilon, which is contained in A. That means, in order to say that S is a neighborhood of a point A means, we need to find epsilon. What is this? This represents epsilon neighborhood of a point A. We find some epsilon neighborhood of a point A. Suppose you assume that this is a subset of a real line. So in order to say that S is a neighborhood of a point A means, you need to provide some neighborhood. A minus epsilon, A plus epsilon, which is contained in the set. If you provide at least one neighborhood around A, epsilon neighborhood around A, which is contained in the set, then one can say that that set is a neighborhood of a point A. So for example, we start with the natural numbers. right? Suppose you can take this counting numbers 1 2 3 4 going on. Question is S is a neighborhood of, suppose you take a point which is less than 1. For instance, we can take minus 0.1. Question is it a neighborhood of minus 1? This S set is a neighborhood of minus 1? The answer no, right? Why? Because if there exists such a neighborhood, such a neighborhood around this, what is the neighborhood around minus 1? Minus 1 minus epsilon, minus 1 plus epsilon. If you take such a neighborhood is possible, which is contained in the set S. But what is my S set? 1 2 3 4 going on. You know, this is an uncountable set. You know, any interval with containing distinct points is uncountable set. We have seen cardinality is continuum. You know, this is a natural number countable set. So absolutely contradiction. If there is such a neighborhood is there, such a neighborhood there, it contains so many irrationals and rational, which should not be contained in the natural numbers, right? In fact, minus 1 contained in the interval, but the thing is minus 1 does not contain here. Of course, this is also contradiction. Minus 1 contained in this interval, but minus 1 should not be in the natural number. So therefore, it's a contradiction again, right? So S cannot be neighborhood of minus 1. Why? Because this, if such a neighborhood is there, minus 1 should be in the neighborhood. But the thing is minus 1 in the set? No. Therefore, our assumption is wrong. Suppose you take this point, or else 1 point. You can take 1 point. Is S in the neighborhood of 1? Is S in the neighborhood of 1? A equals to 1? The answer,
No, sir.
to answer this question, again, same strategy that you start with. If such a neighborhood is there, for some suitable epsilon, it contains so many rationals and irrationals, which is not a subset of your natural numbers. My set is natural numbers. You give me any epsilon. This contains so many rationals and irrationals. It should not be contained in the given set S. Therefore, S is not neighborhood of 1. Similarly, you take this point 1.5, for example. Is it a neighborhood of S is a neighborhood of a point 1.5? The answer again no. You give me any neighborhood, 1 minus 1.5 minus epsilon, 1.5 plus epsilon. You give me any epsilon neighborhood of this. It contains so many rationals, irrational, which should not be contained in. It should not be contained in your given set. This is true for any epsilon. You never provide such a neighborhood, epsilon neighborhood of 1.5, which is contained in the sets. So therefore, this is not a neighborhood of a point A equals to 1. Right? Similarly, you can continue this argument. Is it neighborhood of 2? No, because we find there is no such a neighborhood. You give me such a neighborhood, it contains so many rationals, but after all, this is a countable set. Right? It does not contain this S, does not contain this any neighborhood of 2, any epsilon neighborhood of 2. You give me very small, sir. I'm going to give very small, sir. Even after all, you can take a very small neighborhood. It contains so many rationals and irrationals, which is not contained in the given set. Therefore, S is not neighborhood of a point 2. Similarly, is it a neighborhood of a point this? No. Again, same strategy. It's not contained in this given natural number set. Is it contained? Is S is a neighborhood of 3? No. You give me any such a neighborhood is there, it should not be contained in the natural number. Therefore, what you observe, S is not a neighborhood of all its points.
సార్ ఓన్లీ న్యాచురల్ నెంబర్స్ కే కాదా సార్, లేకపోతే రియల్ నెంబర్స్ అట్లా తీసుకుంటే అయిద్దా సార్?
That's what I'm taking. 2.5 is not a natural number, right? 2.5 is not a natural number. But even though 2.5 is not natural number, but S is not neighborhood of 2.5. You take, for example, 100.1, 1111. Is it a neighborhood? Is S is a neighborhood of 100.1111? No, because you take such a neighborhood. You give me such a neighborhood. మీరు ఎప్సిలాన్ ఇవ్వని చెప్తాను. ఫర్ ఎగ్జాంపుల్ మీరు ఎప్సిలాన్ 0.1 పాయింట్ లేకపోతే 1 ఇచ్చారనుకోండి, 1.0 ఏదో ఇచ్చారనుకోండి, ఏమైద్దమ్మా ఇది? సో 99 1.111. This is what 101.1111, because A minus epsilon, A plus epsilon. But does it contained in the natural number set, this interval? No. So-called action. Therefore, you can never give me such a neighborhood in such a way that that is inside the set. This neighborhood is inside the set. This never happened. Understand? You give me any neighborhood that you give me, it should not be inside the set. This is true for any real number, not only natural numbers. You give me any real number. Neighborhood untadi, but it should not be contained in the given set. Neighborhood is always possible, but the thing is not contained in the given set. What is the set I'm taking? Natural numbers. What I'm taking? Natural numbers. What is my set there, which I defined already? Natural numbers. I'm work with natural number. I'm interested in natural number right now. First example. So therefore, this, suppose you take integers. Okay, is it neighborhood of 0? No, because you give me any neighborhood, it contains rationals and irrational, which is not contained in the natural integers. You take this number, you give me any neighborhood, which is, it contains so many rationals and irrational, which is not inside the integers. You give me this integer, you give me any neighborhood, you give me, which is not inside the set. Right? Is it a neighborhood of this? Suppose you take a point which is inside 1 and 2. Is it a neighborhood of A? Is the set is a neighborhood of A? No, because it contains so many rationals and irrationals by density property. It's not contained in the integers. Is it neighborhood of 2? Is the set is neighborhood of 2? No. The same idea. Same idea. You give me any real number. You give me any real number.
With the real numbers.
Yeah, you give me any real number. And in fact, you give me any radius. You give me any radius. It should not be contained in the integers, because actually Z is a countable set. How can you find a radius which is inside the interval? This is uncountable set, this is a countable set. How can you give such a radius? It's impossible. Suppose you take empty sets. Yeah. Is it neighborhood of 1?
Yes, sir.
Why?
There is no points.
There is no point means?
Empty set lo point.
Yeah, empty set low points window. See, if you give me a point, you need to see what is our game is. If you give me point, I'm going to provide a epsilon neighborhood. Mere point iste nenu epsilon istanu. Etla? That neighborhood which is contained in the neighborhood. Mere point iste. This is our game. What is our game show? If you give me point, I'll provide epsilon in such a way that that neighborhood is inside the set. Can you provide such a point? See, there running race lo participate చేసామనుకోండి. ఒక ఆయన పార్టిసిపేట్ చేయాలి సమ్ ఫిజికల్ ప్రాబ్లమ్స్ వల్ల. ఆయన పార్టిసిపేట్ చేయలేదు కాబట్టి ఎవరు విన్ అవుతారు ఆటోమేటిక్గా? సెకండ్ క్యాండిడేట్ విన్ అవుతాడు. ఇక్కడ మీరు పాయింట్ ఇవ్వలేరు కాబట్టి ఆటోమేటిక్ ఏమవుతుంది? ఇస్తే నేను ఇవ్వాలి ఎప్సిలాన్, మీరు ఇవ్వలేదు కాబట్టి ఆటోమేటిక్గా దిస్ ఇస్ నైబర్హుడ్ ఆఫ్ ఆల్ ఇట్స్ పాయింట్స్. నైబర్హుడ్ ఆఫ్ ఆల్ ఇట్స్ పాయింట్స్ by redundant argument anamata. So empty set is always neighborhood of all its points. Suppose you take a real numbers. You give me any point. You give me a point in the real number. Suppose you give me, for example, root 2. Is it a neighborhood of R? Is it a neighborhood of root 2?
Yes, sir.
Provide such a neighborhood. You give me any epsilon, not only this, root minus epsilon, root 2 plus epsilon, which is inside the set. So therefore, S is neighborhood of root 2. S is neighborhood of root 2. Suppose you take 1. Is it a neighborhood of 1? Is the set is neighborhood of 1? Yes, because I'm going to find an epsilon. I'm going to give a very small epsilon, or you can take any big epsilon. Whatever epsilon you give me, this is contained in the total real line, because we are working with the real line. We are working with the real line. This is after all a part of the real line. 1 minus epsilon, 1 plus epsilon is after all a part of the real line. So therefore, this R is a neighborhood of 1. You give me a point, any point that you take, any point that you give me, I provide a neighborhood. That neighborhood which is inside the even real number. This is true for any point. Therefore, R is neighborhood of A. What is my A? My A is any arbitrary point. Therefore, R is neighborhood of all its points. Because we are working with a real line, once you find a real now right epsilon neighborhood, this is a part of real line. Suppose you are working, you want to work with this point. You find some neighborhood. You take this neighborhood. This is a part of real line. So it is inside the real line. No matter how radius it is. Suppose you take big radius, not matter, because it's a part of real line. So therefore, automatically that R is a neighborhood of all its points. Suppose you take S is equals to rationals. Question is that, suppose you give me 1. Is it a neighborhood of 1? Is the rational numbers neighborhood of 1? The answer no. Right? You give me any neighborhood you give me, it contains so many rationals and irrationals. Rationals and irrationals both are dense. Both are dense set in R. In చిన్నప్పుడు చదువుకుంటాం కదా, any two distinct real numbers, it contains infinitely many rationals and irrationals are there. So therefore, it contains so many irrationals. Of course, there is no problem with rationals. What about irrationals? It contains irrationals, which is not inside Q. Therefore, Q is not neighborhood of 1. Q is not neighborhood of 1. Okay, suppose you take root 2. Is it a neighborhood of Q? Is this a Q is a neighborhood of root 2? Again, the same strategy. Actually, this root 2 itself is not a point of this. If it is contained in this Q, is it possible for some epsilon? No, right? Because root 2 is a member of here, but root 2 cannot be a rational number. ఒకవేళ నైబర్హుడ్ ఇచ్చినా కూడా రూట్ 2 రేషనల్ కాదు కదా. Understand? You never find a neighborhood which is inside Q. Because if such a neighborhood is there, automatically that neighborhood should be in Q. నైబర్హుడ్ లో ఎట్లయినా రూట్ 2 ఉంటుంది కదా, మరి రూట్ 2 రేషనల్ కావాలి కదా మరి ఎట్లయితే. సో రూట్ 2 రేషనల్ కాదు కాబట్టి యువర్ అసంప్షన్ ఇస్ రాంగ్. వాట్ ఈస్ అసంప్షన్? Neighborhood is inside the set is absolutely wrong. Therefore, there is no such a neighborhood which is inside the set. So therefore, you give me any real number, not only this, you give me any real number, you give me any neighborhood which is not inside the set, because rational numbers is a countable set. This is uncountable set. It contains infinitely many irrationals and rationals are there. But rational, there is no problem. What about irrationals? Irrationals here, but irrationals should not be contained in the rational number set. Therefore, Q is not neighborhood of any points. Any of its points. Suppose irrationals, is it neighborhood of any of its points?
No, sir.
The same idea. You take any point irrational, you give me any neighborhood, it contains rationals. It contains rationals. This rational not contained in your irrationals, right? So therefore R minus Q is not neighborhood of root 2. Not only root 2, you give me any real number, you give me any neighborhood which is not inside the set, which is not inside the irrational numbers. Why? Because it contains so many rationals. The problem with rationals, whenever rational is there, should be in R minus Q. But is it true? No. Therefore, you never give me such a neighborhood in such a way that this is inside the set. Therefore, it's not neighborhood of any points. Not neighborhood of any of its points. Yeah. Suppose you take this. One by 2. 1 by 3, 0. Yeah, is it neighborhood of this point? Suppose you take any number which is bigger than 1. Is it neighborhood of, is the set is neighborhood of A? No, right? Because if such a neighborhood is there, that should be contained in your S. Right? If such a neighborhood is there, that neighborhood should be contained in S. Therefore, A is in S. A is in A minus epsilon, A plus epsilon. Therefore, A would be in S. But is it possible A is in S? No, because A is bigger than 1. Nah. The members which are in S are nothing but 1, 1 by 2, 1 by 3, 1 by 4 going on. How can you say that A is any number which is bigger than in S? In A em తీసుకున్నాను bigger than 1 తీసుకున్నాను అంటే ఇక్కడ రైట్ సైడ్ ఏలో ఎట్లుంటది సో ఉండదు కదా so therefore S cannot be neighborhood of a point A. Therefore any number which is bigger than 1 is not neighborhood of that point. Any number, S is a set. You take a real number which is bigger than 1. That S cannot be, neighborhood of that point A. Suppose you take this point. Is it neighborhood of 1? Is the set neighborhood of 1? No. Because this neighborhood contains so many rationals and irrationals. It should not be contained in the set. Is it neighborhood of a point? Is the set is neighborhood of this point? The answer again no, because we find, you give me any neighborhood, this is not inside the set because it contains so many rationals, irrationals. What about this point? It's also not neighborhood of this point. The set is not neighborhood of this point. Why? Because this contains so many rationals and irrationals which is not inside the set. Is it neighborhood of a point? Is the set is neighborhood of a point? No. Right? Going on. You give me anything. Anything you give me. So therefore, S is not neighborhood of any real number. Suppose you take open 0, 1. Yeah, suppose you take this point, a point which is less than 0. Is it a neighborhood of a point? Is the set is neighborhood of a point A? The answer no, because you give me any neighborhood which is not inside the set S. Because this is a less than A is less than 0 na, because A is left side to 0. How can you say that A is inside the set? How can you give me in such a way that epsilon, in such a way that A minus epsilon, A plus epsilon, which is inside the set? No, right? Because this neighborhood contains A, therefore A should be in S. Is it possible A is in S? No, because A is outside the interval. A is outside the interval because I'm taking A is left side to 0. So therefore, we cannot find such a neighborhood inside, which is inside the set. Therefore, S is non-neighborhood of a point A. Is it neighborhood of 0? No, because 0 is not inside the set. Is it neighborhood of a point? Yes. I can provide a neighborhood, very small, teeny neighborhood, which is inside the set. Is it neighborhood of a point? Yes, because I find very small neighborhood, teeny neighborhood, which is inside the sets. Is it neighborhood of a point? Yes, because we find some neighborhood, small neighborhood, teeny neighborhood, which is inside the set. Right? Is it neighborhood of a point? Yes, we find some very small neighborhood. You can take any neighborhood. Suppose my point is X. You can take any neighborhood like this. My epsilon is this. So this is inside this. For this epsilon, this neighborhood which is inside the set. So S is neighborhood of all its points of the set. What about these points? No, right? You take a point here. Is it a neighborhood of S? No, because it's not a member of the set S. It's not a member of the set S. So automatically it cannot be neighborhood of X. So what is my argument? Therefore, S is neighborhood of this point, 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 this point. Therefore, S is neighborhood of all its points. Suppose S is equals to close 0, open 1.
Sir, previous example,
Hmm.
A point we can take lies between 0 to 1. We can take 0.5. Epsilon we can take higher value, maybe 2, 3. But neighborhood does not belong to that set.
See, what is the definition? You need to provide at least one neighborhood. That is the definition. Don't take a very bigger epsilon, because we need to see if you take a bigger epsilon, that doesn't matter. But the thing is, you need to provide such a at least one epsilon or not. such a teeny epsilon or not? That is the definition, not for every epsilon. If you take epsilon is very bigger than 1, sir, what happened? The radius is very big. But what is my definition? You need to provide at least one worst epsilon, at least one good epsilon. Right? See, నేను ఇక్కడ ఫర్ ఎగ్జాంపుల్ 0.5 తీసుకున్నాను. నేను epsilon 1 ఇస్తాను, 2 ఇస్తాను అంటే epsilon 2 is a very big radius, but which is not inside the set. But the thing is, how can you take this epsilon is 2? If you take epsilon is very small radius, this is inside the set, no? This radius, this is inside the set, no? So how can you take very big epsilon? My definition is you need to provide at least one epsilon in such a way that that neighborhood which is inside the set, if that happens, S is a neighborhood of that point. That's what actually definition. Don't need to take a very big epsilon. Suppose you take this point. Is it a neighborhood of A? Is the set is neighborhood of A? No, because it's not a member of the set. Therefore, S is not neighborhood of a point A. Is it a neighborhood of a point? No, because you give me any neighborhood, this left side portion which is outside the set. You give me any neighborhood. What is the neighborhood here? 0 minus epsilon, 0 plus epsilon. Is it contained in the set? Anybody? Is it contained in the set? No,
No,
right?
sir.
I'm going to take a midpoint of 0 and minus epsilon. What is the midpoint of 0 and minus epsilon? Minus epsilon by 2. Minus epsilon by 2 is a neighborhood in the point, but minus epsilon by 2 should not be contained in the set because S contains only positive real numbers, including 0. Therefore, conduction, if there is no such a neighborhood is there, we are going to get a conduction. So therefore, S is not neighborhood of 0. S is not neighborhood of Is it neighborhood of this? Is the set is neighborhood of X? Yes, we can provide very small neighborhood. You give me very small epsilon. Epsilon is less than 1. It's enough. Epsilon you can take like this. If you take this, it's possible. You can very small epsilon that works. Is it a neighborhood of Y? Is the set is neighborhood of Y? Yes. We can find very small teeny neighborhood which is inside the set. Is it neighborhood of this set is neighborhood of 1? No, because 1 does not belongs to S. Is it set is a neighborhood of this point? Suppose you take a point which is bigger than 1. Is it a neighborhood of a point A? No, because it's not a member of S. If the set is not does not contain that point, S cannot be neighborhood of that point. Therefore, S is neighborhood of all its points except 0. Neighborhood of all its points except 0. So what is the notice? Notice is if S is a subset of R, is not containing the point itself. Point A belongs to R. This S cannot be neighborhood of A. That's it. Point set lo lenapudu your neighborhood lo etla untadi because you are going to get a conduction. Right. Suppose you take this example. Is it neighborhood of 0?
No, sir.
Is it neighborhood of A? Is the set is neighborhood of A? No, because it does not that the point is not inside the set because A is less than 0. A is outside the interval. Therefore, S is not neighborhood of A. Is S is the neighborhood of this point? No. Is S is neighborhood of 0? Is S is neighborhood of 0?
No, sir.
No, because the point which is outside, the interval, this left side region, in fact, pink region, therefore, it is outside the interval. Therefore, S is not neighborhood of 0. You take this point, suppose. Is it a neighborhood of X?
Yes, sir.
Yes, because we find some neighborhood, sort of neighborhood with teeny neighborhood which is inside the set. Is it neighborhood of this? Yes, we find a very small teeny neighborhood which is inside the set. Is S is neighborhood of 1? No, because right side to 1 region is outside the set. This region is outside. Which region? This right portion, this portion is outside. This is my neighborhood. 1 plus epsilon, 1 minus. There is no problem with this region. 1 minus epsilon to 1. 1 minus epsilon to 1, there is no problem. The problem comes with 1, the right side portion to 1. It's outside the interval, outside the sets. So therefore, S cannot be neighborhood of 1. You take this point. Is S is a neighborhood of A? No, because it's outside the interval. So therefore, what you observe? S is neighborhood of all its points except 0 and 1. Neighborhood of all its points except its endpoints. Except its endpoints. So suppose you are going to ask the question. See, give me a neighborhood. Give me neighborhood. Neighborhood. Give me not neighborhood. Give me a set first of all. Give me a set which is neighborhood of all its points. All its points except 3 points. Use chart box. Use chart box. Give me a set which is neighborhood of all its points except 3 points. Use chart box. Don't reveal answer. Use chart box.
Sir, can you explain above case 1, sir?
Which one?
Above, yes, sir, this one.
Yeah, this is neighborhood of, see, this is neighborhood of this point. This is neighborhood of this point. This is neighborhood of this point. 0 తో ప్రాబ్లం వస్తుంది ఎందుకంటే లెఫ్ట్ రీజియన్ అవుట్ సైడ్ ఉంది కదా, నైబర్హుడ్ ఇచ్చారు అనుకోండి, ఈ లెఫ్ట్ సైడ్ రీజియన్ ఇస్ నాట్ కంటైన్డ్ ఇన్ ద సెట్.
Yes, sir.
ఈ 1 తీసుకున్నారు అనుకోండి, యా ఏ తీసుకుంటే ఆ సెట్ లో ఉండదు కదా. నోట్ ఏమని రాయించాను ఇంతకుముందు, సెట్ లో పాయింట్ లేకపోతే అసలు దట్ కెనాట్ బి నైబర్హుడ్ ఆఫ్ ఏ పాయింట్. ఏ అనే పాయింట్ సెట్ లో
Yes.
ఉందా?
No,
therefore
sir.
S cannot be neighborhood of a point.
Yes, sir. Thank you, sir.
Okay. Give me a neighborhood which is neighborhood of all its points. Yeah, good, very good. Ramesh. Yeah, Ramesh, 0, 2, 3. Yeah, good, but yeah, so Shivrasad garu good. Shravanti. Okay. So I need to have a set which is neighborhood of all its points except 3 points. See, we have seen just now is neighborhood of all its points except these 2 points. The problem with 2 points, you add 1 point, 1 more point. You add 1 more point, that's it. Yes or no? This is not neighborhood of this point. The set 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 is not neighborhood of this point. This is neighborhood of this point, 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 except 0, 1, 2. Set లో ఉన్న పాయింట్స్ ఏంటి? 0 దగ్గర ప్రాబ్లం అవుతుంది, 1 దగ్గర ప్రాబ్లం అవుతుంది, 2 దగ్గర ప్రాబ్లం అవుతుంది. Therefore S is neighborhood of all its points except which points? 0, 1, 2. సెట్ లో పాయింట్సే కదా. నైబర్హుడ్ ఆఫ్ ఆల్ ఇట్స్ పాయింట్స్ ఎక్సెప్ట్ 3 పాయింట్స్ అన్నాను. 3 పాయింట్స్ దగ్గర మాత్రం ప్రాబ్లం అయ్యేటట్టు ఇవ్వండి అన్న. ఇప్పుడు ఇదే క్వశ్చన్, గివ్ మీ నైబర్హుడ్ ఆఫ్ ఎ పాయింట్ which is neighborhood, give me a set which is neighborhood of all its points except 4 points. Anybody? Give me a set.
రెండు క్లోజ్డ్ ఇంటర్వెల్ తీసుకుంటే సరిపోతుంది సార్.
Yeah, I know.
Union
Yes.
of two closed intervals.
Give me an example of a
Closed CD.
which neighborhood of points, which neighborhood of all its points except 4 points. So as he said, this is enough. So this is not neighborhood of this point. The set is not neighborhood of B point. This set is not neighborhood of C. This set is not neighborhood of D. Now the same question, give me a set which is neighborhood of all its points except n points. Yeah. Give me a set.
1 union, 2 union, 3 union, up to so on n.
Give me an example of a set which is neighborhood of all its points. All its points except its endpoints. Endpoints. So 1, you can take 1, you can take 2, or else, right? You can take 3, 4. You can take n plus 1. It's enough, right? Yes or no? So the problem comes with 1, the problems comes with 2, the problems comes with 3, the problems comes with n. Therefore, the problem troubling points are n points. Remaining points, there is no problem. Therefore, it is neighborhood of all its points except 1, 2, 3, 4, 5 up to n, where n is a fixed positive integer. Now, give me a set which is neighborhood of all its points except countable infinite points. Use chart box. Use chart box.
Excuse me, sir.
Yeah.
Here, why did you take open bracket, closed bracket 1, 2 open bracket, sir?
See, for the sake of our convenience, that's it. Sake of our
Can take
convenience.
closed bracket, sir. Closed bracket 1, 2 union, closed bracket 2, 3 also, sir.
అట్లా తీసుకుంటే పాయింట్స్ డబుల్ అవుతాయి కదండి. ఇట్లా తీసుకుంటే ఏమైతే పాయింట్స్ n+1 పాయింట్స్ అవుతాయి. అన్ని దగ్గర నైబర్హుడ్ అవుతుంది. n పాయింట్స్ టుగెదర్ విత్ 1 కదా. ఇది యాడ్ చేసి అనుకోండి, యాడ్ చేసి ఏమొస్తుంది 1, 2, 3, 4, 5 n+1. నేను కావాల్సిన ఎన్ని అన్నాను, ఓన్లీ n పాయింట్స్ అన్నాను కాబట్టి దీన్ని డిలీట్ చేసేయండి, ఇది నాకు అవసరం లేదు. ఒకవేళ మీ క్వశ్చన్లో n+1 అంటే యాడ్ చేయండి, మీ క్వశ్చన్లో n+1 అంటే యాడ్ చేయండి, n+2 అంటే ఇది యాడ్ చేయండి. అర్థమవుతుందా? అకార్డింగ్ టు అవర్ ఆన్సర్, అకార్డింగ్ టు అవర్ క్వశ్చన్. కౌంటింగ్ పర్పస్, ఈజీ పర్పస్ ఉండడానికి చేస్తాను అంతే. సో give an example of a set which is neighborhood of all its points except its countably infinite points. Yeah, give me set. ఇచ్చారా? Yeah. Good, Naresh Kumar. Good, very good. Countable infinite points. Don't stop. I need to have a countable infinite. I'm not saying countable set. So what I'm taking is 0, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, going on. The troubling point 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 4, 13, 14, 15, 16 going on means what? Troubling points are countable in points. What are the troubling points? End points, left end points. So it is neighborhood of all its points except these points, Yeah, ఇట్లా ఇచ్చి కొంతమంది ఇట్లా ఇచ్చారు, వెరీ గుడ్, వాళ్ళు కూడా వెరీ గుడ్. ఇట్లా ఇచ్చారు, ఇది కూడా ఓకే. కొంతమంది ఇట్లా ఇచ్చారు, నేచురల్ నెంబర్స్ ఇచ్చారు, ఇది కూడా ఓకే. బికాస్ నైబర్హుడ్ ఆఫ్ ఆల్ ఇట్స్ పాయింట్స్ ఎక్సెప్ట్ 1, 2, 3, 4 ఇట్లా రాసేయండి. సో ప్రాబ్లం ఏంటి ఇక్కడ? ప్రాబ్లం దేంతో వస్తుంది? దేంతో వస్తామా? 1, 2, 3, 4, 5 వీటితో వస్తుంది. దీంతో ప్రాబ్లం రాదు. ద పాయింట్స్ విచ్ ఆర్ ఇన్సైడ్ ద సెట్, నో ప్రాబ్లం. దిస్ ఇంటర్వెల్ ఇక్కడ ఈ పాయింట్ తీసుకున్నాను అనుకో, యూ కెన్ ఫైండ్ సమ్ నైబర్హుడ్ విచ్ ఇస్ ఇన్సైడ్ ద సెట్. సో దిస్ ఇస్ నైబర్హుడ్ ఆఫ్ ఆల్ ఇట్స్ పాయింట్స్. only problem with 1, 2, because you never find such a neighborhood which is inside the set. 3 తో కూడా వస్తుంది, 4 తో కూడా వస్తుంది, నా ప్రాబ్లం. ఓకే, దిస్ ఆల్సో రైట్ ఆన్సర్. కొంతమంది ఇచ్చారు, వెరీ గుడ్. Okay, next is, suppose S is a neighborhood of a point R. Suppose S is a neighborhood of point A. So you take any superset. You take any superset. T is also neighborhood of the same point. Means superset of any neighborhood of a point A is a neighborhood of a point. Neighborhood of that point. Why? Suppose S is neighborhood of A. What do you mean by S is neighborhood of A? We find some neighborhood, epsilon neighborhood, A minus epsilon, A plus epsilon, which is inside the sets. But we know that S is contained in T. Therefore, we find the same neighborhood which is inside the T. Therefore, we find some epsilon neighborhood which is inside the T. Therefore, T is neighborhood of a point A. Therefore, any superset of neighborhood is again a neighborhood of that point. Superset of neighborhood is again a neighborhood. What about subset? Subset of neighborhood, is it a neighborhood of that set, that point?
Need not.
Need not be. If you take R, R is neighborhood of A, any real number. Suppose for instance, R is a neighborhood of a point, you can take 1. Suppose you take Q is a subset of R. Is Q is a neighborhood of 1? Is Q is a neighborhood of 1? Anybody?
No.
No, right? Because we find, you give me any neighborhood which is not inside the set. Which is not inside the set, not inside the set, because it contains so many rational numbers. So Q is, there exists at least one subset of R, which is not neighborhood of 1. So subset of neighborhood may not be neighborhood of that point. Of course, it can be sometimes. Open 0, 1 sub you take. Suppose open 1, 2, open 1, 3. Suppose 0, 3, sorry. You can take 1, you can take open 0, 3. So automatically, you know, this is subset of R. This is subset of R, which contains 1. Is it neighborhood of 1? Yes. Because I find very small neighborhood, teeny neighborhood, which is inside the set 0, 3. So therefore, open 0, 3 is a subset of R, which is neighborhood of 1 also. Therefore, subset of neighborhood of that point may be or may not be a neighborhood of that point. But superset always.
Similarly, it can, in this one 0 to 3, it can be a subset of 2 also, sir.
0 to 2?
Yeah,
0 to 2 is also okay. The problem is only 1.
Okay, sir.
0 to 2 okay. 0 to 1 ఎందుకు తీసుకోవట్లేదు అంటే 1 సెట్ లో ఉండదు కదా, ఫస్ట్ సెట్ లో ఉండబోదు కాబట్టి. సో దర్ఫోర్ ఇట్ కెనాట్ బి నైబర్హుడ్ ఆఫ్ దట్ పాయింట్.
సార్ ఇక్కడ కింద సెట్ లో
అది ఇది ఒకటే అమ్మా.
నంబర్ లైన్
సి అది ఇది ఒకటే సెట్, అదే ఇక్కడ నెంబర్ లైన్ రాశాను. ఓకే, ఇదే ఇక్కడ డిస్కస్ చేసాం, ఇదే ఇక్కడ డిస్కస్ చేశాను. ఓకే, ఈ సెట్ ఇక్కడ డిస్కస్ చేసాం. ఓకే, సో therefore this is what actually property. Next property is, suppose A is a neighborhood of a point, B is a neighborhood of a point, both are subsets of R. So does it mean that intersection is also neighborhood of a point A?
Sir.
Yes. So therefore that means if A is an A and B are neighborhood of a point A, then automatically this intersection also neighborhood of that point. Right? Intersection also neighborhood of this point. This is also important notice. Question is it true for only 2 sets? See, you can prove, you can take any textbook, you can prove it. See, is it true for only two sets, or is it true for finite sets? Suppose A1, A2, A3, AN, where n is a natural number, fixed natural number, a neighborhoods of a point A. So that is mean that finite intersection you take. Is it a neighborhood of a point A?
Yes, sir.
Yes, you can take a very small teeny neighborhood, which is inside the set. So question is, can we extend this idea to arbitrary intersection? If A1, A2, A3, going on, are neighborhoods of a point A, does it mean that you take the arbitrary intersection or countable intersection? Is it a neighborhood of a point A? Is it true actually?
Need not to be.
Yeah. Can you give example? Use chart box. Use chart box. See, if you take the finite intersection, there is no problem. Finite intersection of a neighborhood is again a neighborhood of that point. But if you take a arbitrary intersection, that need not be, somebody said, but give a counter. Suppose you take this, yeah. So Bhutta Shivaprasad, see, that must be open interval, right? Because the problem with left hand point, there is a problem. So you need to take the open brackets instead of taking closed brackets.
Okay, sir.
Because it's not neighborhood of endpoints. Okay, good, very good. Shivaprasad got a very good. Okay, suppose I'm going to take this. For instance, I'm going to take this AN is simple standard example is -1 by n, 1 by n, where n equals to 1, 2, 3, 4 going on. It's a segment, open interval. Is neighborhood of all its points. We have seen any open interval is neighborhood of all its points. Any open interval is neighborhood of all its points. We have seen. Therefore, it's neighborhood of. In fact, it's neighborhood of. I'm going to take 0. So each AN is A1 is a neighborhood of 0. A2 also neighborhood of 0. What is A2? -1 by 2, 1 by 2. Understand? What is my
set, sir?
What is my A1? -1, 1. What is my A2? -1 by 2, 1 by 2. What is my A3? -1 by 3, +1 by 3. So going on. Therefore, is neighborhood of 0. There is no problem because it's a segment. It's an interval. Interval is always open interval. Is neighborhood of all its points. In fact, it's neighborhood of 0. So therefore, each A1, A2, A3, A4, A5, A6 is neighborhood of 0. Question is it neighborhood of 0 intersection?
No, sir. Finite set is the singleton set 0.
Yeah. This is what is the intersection?
0.
Yeah, use chart box.
Singleton set 0.
Singleton set 0 by Archimedean property, or else you can take any standard result. You take any member that should be contained in each S. So what is my n? An is actually -1 by n plus 1 by n. Therefore, x should be in -1 by n plus 1 by n. Therefore, by this argument, mod xn is less than this for every n. So therefore, mod x is always non-negative. Letting n tends to infinity by sandwich theorem, this tends to 0, this tends to 0. Mod x tends to 0, but mod x is a constant. Constant of the limit is constant. Therefore, mod x is equals to 0. Mod x is 0 if and only if x must be 0. Therefore, you take any point which is an intersection, that should be 0. Therefore, that intersection is singleton 0. That intersection is singleton 0. Therefore, is it a neighborhood of 0? Is singleton 0? Anybody? What is my set? Singleton 0. Is it neighborhood of 0? No.
No,
Give
sir.
me any neighborhood. It contains so many rationals, irrational. It should not be contained in singleton. ఇలా చాలా పాయింట్స్ ఉంటాయి. సింగిల్టన్ 0లో ఉండదు కదా ఇవన్నీ. So therefore, what you observe? This intersection is not neighborhood of 0. But each an is neighborhood of 0. We have seen. Because each n is a segment. Each n is an interval, open interval. Therefore, each n is a neighborhood of 0 But the thing is, intersection cannot be neighborhood of 0. Intersection cannot be neighborhood of 0.
Another example, 1, n is the neighborhood of sorry, arbitrary intersection cheste.
What?
1, n. Arbitrary intersection cheste neighborhood వస్తుంది మళ్ళీ.
Yeah, it may or may not be. That's what my point. It may or may not be. You take this interval. What is intersection? What is intersection? Yeah, anybody? What is intersection? 1, 2, 1, 3, 1, 4. What is intersection?
1.
1, 1.
1, 5. What is intersection? Anybody? See,
One,
first set
sir.
low.
Sir, 0,
1, sir. 1, sir.
Open interval 1,
Open interval 1, 2. Good. Who said?
Pandu, sir.
Yeah, very good, very good. Open interval 1, first set is what? Actually, open interval 1, 2. Second set is 1, 3. Third set is 1, 4. Fifth set is what? 1, 5. Sixth set is what? 1, 6. What is the least set? This one, right? So therefore 1, 2 is neighborhood of all its points because the segment is an open interval. Therefore, it's neighborhood of all its points. So arbitrary intersection of neighborhood of a points may not be neighborhood of a point. Suppose you take union. What about union?
is always neighborhood, sir.
You take A and B, which are neighborhoods of a point A. Question is a union, is it a neighborhood of a point A? Yes, we have seen superset of neighborhood is again a neighborhood. You know, A union B contains A, so it's a superset of A, therefore is a neighborhood of A. This is what actually proves. Superset, we have seen superset of neighborhood is again a neighborhood. A and B is after all a superset of A, therefore A and B is automatically neighborhood of a point A itself. Right? So union of neighborhood is again a neighborhood. Not only these two members, you take any arbitrary union. We can extend this idea to arbitrary collection. Therefore, arbitrary union of neighborhood of a point A is a real number, is again a neighborhood of that point.
Previous example, sir. Minus
Yes,
1 by n, 1 by n, open interval.
Yeah, this is about actually it's the same idea that A and B contains A itself. Superset of a neighborhood is again a neighborhood. Superset of a neighborhood is again a neighborhood. Right? So next is open set, interior points. Next I'm going to take that interior point. Okay. So you take any subset of a real line, right? It start with a member which is in S. If a member which is not in S, it cannot be interior point. So S is that point is an interior point. The point is said to be interior point. If only it should be neighborhood of A. That's it. We have seen what is meant by neighborhood of a point A. What is meant by neighborhood of a point A? We need to provide at least one neighborhood, at least one epsilon neighborhood, in such a way that that neighborhood is inside the set. Right? You need to provide at least one such a worst neighborhood or good neighborhood which is inside the set. If that happens, that point is an interior point. See, in order to say that something is interior point, that should be a point of the set. That should be a point of the set. Otherwise, it cannot be interior point because that point, that S is a neighborhood of that point itself. So whatever example you studied so far, suppose you take this finite sets. Is one is an interior point of the set?
No, sir, there does not exist neighborhood.
Because as you seen that S is not neighborhood of 1, na? So 1, 2, 3. So therefore, Yes, cannot be. Is it neighborhood of 1? No, because we cannot provide a neighborhood which is inside the set, because this neighborhood contains, the shaded region contains infinite rationals and irrational, which is not inside the set. Therefore, S is not neighborhood of 1. S is not neighborhood of 1 means what? It cannot be interior point. Is it interior point? No, because we never provide a neighborhood in such a way that which is inside the set. Therefore, 2 also no. Is 3? Is 3?
3 is also not
No,
interior.
right? They never find a neighborhood which is inside the set S. Is it neighborhood of a point? Suppose A is bigger than 3. Is it neighborhood of a point? Is it an interior point? No. Because already told you, whenever something you want to say that it's an interior point, that should be a point of S. Is it a point of S? I'm taking
No,
only
sir.
finite set. So therefore it cannot be interior point. So what are the interior points? No point is interior point. S has no interior point. Suppose you take a counting numbers, natural numbers. Does it have interior points?
No,
No.
No, sir.
The same idea which works. So S is not neighborhood of 1. S is not neighborhood of 2. S is not neighborhood of 3. Therefore, S cannot be neighborhood of none of the points we have seen. Therefore, it has no interior points. Suppose you take these integers.
no,
It is
sir.
also no.
So we have seen that S is not neighborhood of none of these points. None of the points we have seen. S is not neighborhood of any of its points we have seen. Therefore, it has no interior points. Suppose S is equals to open 0, 1. Yeah.
Yes, sir.
Yes, we have seen S is neighborhood of all its points.
All of
We have
its
seen
point.
we have seen S is neighborhood of all of its points. This S is neighborhood of this point. 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 So every point, when you take any point of S, that set is an neighborhood of that point. Therefore, every point is of S
Interior point.
interior point. Okay. So S close it to open 1.
Except 1 and point 0.
Yeah, we have seen that S is neighborhood of all its points. Only the tripling point is 0. Therefore, S is not neighborhood of 0. So every point is interior point because S is neighborhood of all its points except 0. Because S is else fails to have a neighborhood at 0. So therefore, so every point of S, because we never provide a neighborhood, this left region is outside. Every point is interior point of S except 0. Yeah. Is it neighborhood of all its points?
Except 2 endpoints.
Yes, except 2 endpoints. These are the troubling points. So therefore, the same region. We take S is equals to -1 whole power n, such that n belongs to n. Does it have interior points? What is my set? When you take n equals to 1, -1. When you take n equals to 2, 1. When you take n equals to 3, again -1. When you take n equals to 4, again
No,
1
sir.
come.
Empty set.
So it is a finite set. Does it
Sir,
have
yes.
interior points?
No, sir.
No. Because you give me any neighborhood, this neighborhood contains infinite rationals and irrational, which is not inside the set. Is it neighborhood of 1? No. Which is the neighborhood contains so many rationals, irrational, which is not inside the set. So it's no interior points. Okay. Yeah. Tell me. Use chat box. Use chat box.
Open interval minus infinity comma 1 union 1 minus 1 comma infinity plus 1 comma infinity.
Yeah, that means every point is integer point. Huh?
Sir, yes, sir.
Yeah, we'll see. So when you take a point in S that satisfies the condition, that satisfies the inequality this. Therefore, 1 by x minus x is positive. That means 1 minus x square by x is positive. 1 minus x square multiply and divide by x when x is non-zero. Right? This is true. Therefore, 1 minus x square into x by x square is always positive. 1 by x square is always positive because when you take x is non-zero, x square is always positive for every x is non-zero real number. Right? So once it is positive, this is also positive. No? Product of positive is positive, they have the same sign. So again, multiply with negative sign. This is x square minus 1. Multiply with minus, we're going to get less than 0. Again, plot number line technique, x minus 1 into x plus 1 into x, which is less than 0. So therefore what? This is 0, 1, minus 1, 1. Right side plus, left neg plus, minus. I require to have only negative region. Therefore, what is the negative region? Minus infinity to minus 1, union 0 to 1. So this is my set. What is my set? Minus infinity, minus 1, union 0, 0 comma open interval 0 comma 1. Question is it neighborhood of all its points?
Yes, sir.
So, yeah, what is my set? My set is here to here, union 0 to 1. Thing is it neighborhood of this point? Yes, we can provide such a neighborhood, wonderful neighborhood, teeny neighborhood, which is inside the set. Is it neighborhood of the point? Yes. Therefore, this is interior point. Is it neighborhood of this point? Yes. We find a very small neighborhood which is inside the set. So therefore, S is neighborhood of all its points. Therefore, every point of S is interior point. Yeah. So with this, I conclude. By tomorrow, I'm going to finish this interior points and open set and limit points concepts. With this, I conclude. You have any doubt? Ask.